There are many methods to solve a quadratic. So far, you've solved for the square, and once you got the square by itself, you were able to take the square root of both sides and do the plus or minus and find both answers. You have solved by factoring. There's another method called completing the square, and completing the square is what leads to the quadratic formula. This year in math, because of the pandemic, we are not going to be able to do the completing the square, but you need to be familiar with the quadratic formula. And that's all it is a formula. So the rule is that it must be written in standard form. Standard form of a quadratic is ax squared plus bx plus c equals 0. Once you have it equal to 0, it must be equal to 0. A is the number in front of the x squared. B is the number in front of the x. And C is the number that's added after. Now notice A, B, and C, x is not part of that. It's the numbers in front of the x squared for A, in front of the x for B, and C is the number added. So for example, if I had 3x squared minus x plus 2 equals 0, a would be equal to 3. B is the number in front of the x, would be negative 1. And C would be equal to 2. Once you have the formula in the right form, and you're able to read off A, B, and C, the quadratic formula works like this. X equals the opposite of B, plus or minus, that's where the two answers come from, square root of B squared minus 4AC all over 2A. So all we have to do is plug in the numbers and very carefully follow the order of operations, and we can work out both answers. This will give you the same answer you would get factoring, the same answer you would get by solving for the square, but a lot of times our answers aren't very nice. They're very messy, and the quadratic formula makes that a lot easier. So this is what you need to know right here to solve the following problems. I have 6 examples for you. The first 3 are the same type, and then the last 3 are the most unfriendly. So if after this first example you think you got it, you need to, at the very least, skip a couple of examples ahead and take a look at the last 3 examples, because they end up with answers that are a lot more unfriendly. The first thing you're going to notice here is this is written in standard form. Notice how it's equal to 0. A is in front of the x squared. A is 1. B is in front of the x. B is 12. C is the number that's added at the end. C is 32. If I was doing this question, the first thing I would try is to see if it factored. Are there any factors of 32 that add to 12? Well, factors of 32 are 1 and 32, 2 and 16, 4 and 8. Do any of those add to 12? Uh-oh, 4 and 8. So this thing actually factors. My recommendation is to use factoring whenever possible because it is quicker. I will do it both ways here so you can see how this looks with the quadratic formula and see that you get the same answer. So by factoring, let's just notice there are factors of 32 that add to 12 are 4 and 8. So this ends up being x plus 4 times x plus 8 equals 0. It's exactly the same as this equation. Notice that 4x and 8x, when you FOIL, end up making a middle term of 12x. And the idea of solving by factoring is that 0 times anything is going to be 0. So the solutions come from what you plug in that makes 0. So our answers are x equal -4 and x equal -8. -4 plus 4 is 0. 0 times anything is 0. -8 plus 8 is 0. 0 times anything is 0. This will look a little bit more confusing when I use the quadratic formula, but you'll see I still get the same answers, -4 and -8. So let's give this a try. So the formula is x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2 times a. So here we get x equals the opposite of b. B is 12, so -12 plus or minus square root of b squared. That's 12 squared. 12 squared is 144 minus, there's a 4 in the formula, 4 times a times c. A was 1 and c is 32. Now this is all over 2 times a, and a was 1. So this is equal to -12 plus or minus the square root of 144 minus 4 times 32 is 128 all over 2. I'll go sideways here. 144 minus 128 is 16. So this is -12 plus or minus the square root of 16 over 2. This is -12 plus or minus the square root of 16 is 4 over 2. Now there are two answers here. One is -12 plus 4 divided by 2, and the other is -12 minus 4 divided by 2. Well, -12 plus 4 is -8 divided by 2, and -8 divided by 2 is -4. -12 minus 4 is -16 divided by 2, and -16 divided by 2 is -8. And you can see I get the same two answers as I do by factoring. Now again, if you can factor, factor. It's quick. The quadratic formula is really for problems that don't have real nice answers. And factoring is the quickest way to solve a quadratic if you can factor. Remember, when you punch this in, you need your two answers, -4, comma, -8. As we look at this next example, you'll see it doesn't factor. There are no factors of 5 that add to 12. So this doesn't have nice answers. So we're going to have probably square roots in our answers. But let's read off A, B, and C. A is the number in front of the square, so A is 1. B is the number in front of the x, it's -12. C is the number that's added or subtracted at the end, here it's 5. If that had been -5, C would have been -5. So our quadratic formula is -b plus or minus the square root of b squared minus 4ac all over 2a. So it's x equals the opposite of b, which is 12, plus or minus b squared, which is 144, minus 4 times a times c, that's 1 times 5, all over 2 times a, which is 2 times 1. All right, we'll go sideways for a bit here. 12 plus or minus square root of 144 minus 20 all over 2. Now I'm going to go below. That's 12 plus or minus the square root of 124 divided by 2. Now, this is where we have to go back and remember that some square roots can be simplified. I believe there's a perfect square in 124. Perfect squares, remember, are 4, 9, 16, 25, 36, 49, and so on. I'm thinking that maybe 4 divides into it. So we'll take our calculator and divide it by 4. It's 4 times 31. So this is 12 plus or minus the square root of 4 times 31 over 2. We can take the square root of 4. It's 2. Now that goes out in front of the root, not in front of the plus or minus. In front of the root we have 2 because the square root of 4 is 2. 2 root 31 over 2. Now you have to think of 2 root 31 over 2. 2 root 31 over 2 like 2x over 2. Because there's multiplication here between the 2 and the root, those 2's can divide. You can cancel them. But then you have to remember that both 2 root 31 is divided by 2 and 12 is divided by 2. So this can be simplified because they both divide evenly by 2. If they both didn't divide by 2, we wouldn't be able to do this. That would be our answer. But since 12 divides by 2 and I get 6, and 2 root 31 divides by 2, the 2's cancel, they're both whole numbers. It's root 31. That is our answer right there. Now when you punch this in WAMAP, it's expecting 2 answers separated by a comma. Well, they're both there. One answer is 6 plus root 31, comma. The other is 6 minus root 31. Now, as strange as it seems, that's what you put in WAMAP. If I pick one of those answers and plug it in for x, easiest way to do that is by storing it on a calculator. You'll see that it works. It makes that equation true. One more example here. You'll notice that there are no factors of 2 that add to 4. That thing does not simplify. So let's read off our A. A is 1 in front of the square. B is 4. That's in front of the x. And C is the number added at the end. It's 2. So we'll write down the quadratic formula. And we'll plug in our numbers quickly. This does go fast once you learn what you're doing. The opposite of b, negative 4, plus or minus b squared is 4 squared is 16, minus 4 times a times c, that's 1 and 2, all over 2 times a, 2 times 1. This is negative 4 plus or minus the square root of 16 minus 8 over 2. So this is negative 4 plus or minus the square root of 8 over 2. Square root of 8 does simplify because it has a perfect square in it, a perfect square of 4. So this is negative 4 plus or minus, and root 8 is 4 times 2. So the square root of 4 will go out front as a 2 in front of the root, not in front of the plus or minus. It's negative 4 plus or minus, square root of 4 is 2, 2 root 2 over 2. And just like the last example, 2 root 2 divides by 2, and 4 divides by 2. This will only work if both numbers up top are divisible by 2. Now understand, 2 root 2 is one number. It's like 2x. I can't divide the root 2 by 2 anyway, and don't do it. It's just like when I say 2 times 8 divided by 2, that's 16 divided by 2, which is 8. Notice if I cancel the 2's, I get 8. It's exactly the same situation. So we can simplify this. Divide them both by 2. It's negative 2 plus or minus root 2. And then for WAMAP, we're going to split up the answers. We're going to say one of them is negative 2 plus root 2. And the other answer is negative 2 minus root 2. So I've got 3 more examples here, and you may not need them all, but these next 3 have messier answers. They don't simplify. So actually they end up being easier, a little trickier to plug in, but in WAMAP I gave you examples below to show you how to plug them in. And remember, in WAMAP there's a little arrow right here you can click on. If you like, you can click on that and it'll bring up an equation editor that will help you plug it in. So the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. You can Google quadratic formula, and there's music videos just for fun if you're curious sometime. But we just plug in our numbers, the opposite of b. So there's my a and my b and my c. So a is 2, b is negative 7, and c is negative 10. Opposite of b is 7 plus or minus square root of b squared. It's negative 7 squared. Now keep in mind, it's negative 7 squared like that, not negative 7 squared like that. This one's negative 49. This is the correct one. That's positive 49. So it's negative 7 squared, which is positive 49, minus 4ac. That's 2 times negative 7, all over 2a. And a was 2. So x equals 7 plus or minus the square root of 49. Now notice the negative right here and the negative right here. It's going to end up being 2 negatives make a positive. In other words, this sign is going to end up being plus. And 4 times 2 is 8, and 8 times 7 is 56. And this is all over 4. And 49 plus 56 is 105. So this is 7 plus or minus the square root of 105 divided by 4. Now the question is, does 105 have any perfect squares in it? You could go to some of the factor tables. I've shown you multiple ways to do that. There's the spreadsheet. If you go to the calendar, there are sites like mathisfund.org where you can get a table, one that'll give you all the factors. I know the rules for divisibility. If you sum the digits, 1 plus 0 plus 5, you get 6. And for the divisibility rule for 3 is, if 3 divides the sum, it divides the number. 3 is not a square, though. But I'm just looking to see what factors are left. 105 divided by 3 is 35. And 35 is 5 times 7. There's no perfect squares in there anywhere. So this is actually your answer right there. No more work required. But again, in WAMAP, you're going to have to split these answers up. 7 plus the square root of 105 divided by 4, and 7 minus the square root of 105 divided by 4. And in WAMAP, it's going to require you to put parentheses here so it knows where the fraction bar stops and ends. Again, there's examples in WAMAP under the answer box that shows you how to plug it in. A, B, and C here. A is 12, B is 9, and C is negative 9. A, B, and C. And the quadratic formula. I'm writing it down every time so you can look at it as I'm plugging in the numbers. So x equals, the opposite of b is negative 9 plus or minus b squared is 81 minus 4 times a times c. That's 12 times negative 9 all over 2 times a, 2 times 12. So this is negative 9 plus or minus the square root of 81. And just like the last one, we've got a negative here and a negative here. Two negatives are going to make a positive. So this will be plus. 4 times 12 is 48. And 48 times 9 is 432. 432. All over 24. And 432 plus 81 is 513. So negative 9 plus or minus the square root of 513 over 24. Now the question is, does 513 have any perfect squares in it? I'm going to use my Google factor table and look at the factors. So factors of 513, 1 and 513, we're looking for perfect squares. 3 and 171, and 9 and 57, ooh, 9, huh? So right there we do have 9 times 57. 57 doesn't have any perfect squares in it. So it looks like 9 is our perfect square. So we will rewrite this as negative 9 plus or minus the square root of 9 times, let's see, and I already forgot, 513 divided by 9 was 57. 57 doesn't have any larger perfect squares in it. It is divisible by 3. 57 divided by 3 is 19, but 19 is prime, so that's our biggest perfect square. So this ends up being negative 9 plus or minus, square root of 9 is 3, 3 root 57 over 24. Now we haven't had one like this, but this does simplify. Remember how in previous question, how I showed you that you could divide, but 9 and does not divide by 24, and 3 does not divide by 24, but they do all have a common factor. They're all divisible by 3. So if we divide them all by 3, negative 9 becomes negative 3. When I divide 3 root 57 by 3, the 3's are gone. It's 1 root 57, or just root 57. 24 divides by 3, and you get 8. So right there is my answer, and we can split that up into two answers. It'd be negative 3 plus root 57 divided by 8, and negative 3 minus root 57 divided by 8. That's a bit tricky, but this is your first experience anything like this, and it just takes some getting used to, and it will get easier in time. Last example. There's our A and our B and our C. So A is negative 10, B is 9, and C is 6. I'll write down the quadratic formula. So let's plug in our numbers. X equals the opposite of B, which is negative 9, plus or minus the square root of B squared, which is 81, minus 4 times A times C, so negative 10 and 6, all over 2 times A, 2 times negative 10. This is negative 9 plus or minus the square root of 81. Now again, we have the double negative. That's going to be a positive. And 4 times 10 times 6 is 240. All over negative 20. Let's go over here actually. X equals, so negative 9 plus or minus the square root of 321 divided by negative 20. So now we're going to look for perfect squares in 321. I'm going to guess that there aren't any, but let's take a look. 321. So we're looking for perfect squares. Ignore the decimals. It's 3 times 107. 107 is prime, I believe. So there are no perfect squares in 321, which means we're basically done. Now, you could leave the answer like this and split it into two answers, but I will point out quite often when we get an answer with a negative below, I'm talking about that right there, you can get rid of that negative. You can put it up, take it off the bottom and put it through the top. Now, remember that top is one thing. So if you take the negative off the bottom and put it through the top, you have to distribute it, which will change the signs. Now you could WAMAP will accept this. If you split it into two answers and put it in WAMAP, it will accept it. But I'm going to do what I would normally do in class, which is I'm going to take the negative off the bottom and distribute it through the top. So when I distribute it through the top, negative 9 becomes 9, the plus becomes a minus, and the minus becomes a plus. The two signs change, but it's still plus or minus. So these two answers are equivalent. And this is a little bit cleaner answer. That's the answer I would prefer. So in WAMAP, our final answer will be 9 plus the square root of 321 divided by 20, and 9 minus the square root of 321 divided by 20.